Sta Tawkari Bashiduam. Now we continue the second part or second requirement of the stairs. Or stair. The subject is stairs. Well, this is example. This is the second example. This is part B. Part B, design the stair if it is supported longitudinally. Design the stair if it is supported laterally or transversely. Sometimes we write transversely. Then we have the slabs. This is the walls that supporting the stair. This is the stair. Oh, stair, come on. This is the stair. This is the stair. This is the stair. The steps of the stair. This is the steps of the stair. Wow, this is the steps of the stair. If it is supported laterally, what we do if the support is lateral? At that time, this is walls, whichever the walls. If we take a section here, this section AA for example, we see this section this way. This is the walls, this is the stair. This is the stair. This is the supporting wall. This is the supporting wall. This is the supporting wall. And the load applied in this way. This cantilever. Transverse laterally, transverse support, laterally support. Here just we have the support here at one location. وليرة أبيتها cantilever. وكو cantilever تعامل لك. أجر section كي بسيط ليرة والgreen. Section B, for example. This is our stair. This is steps or going. This is step. 300 millimeter. We sometimes we call it going or straight. We say it's straight. Well, this is riser. This is, we called it riser, equal to 180 millimeter in this problem, and so on. This is another steps. Here, this is, we called it steps, west. This is, we called it west. Thickness of the slab, edge, we write here edge. Here we write it edge chanaka, according to the slab in cantilever kata L n over 10, 1 over 10. Then this is 1 meters. Then lero hata era 1 meter. 1 meter. Then is equal to hazar 1 meter. Over 10 is equal to 100 millimeter. This thickness is 100 millimeters. The thickness of the stair or west or slabs is equal to 100 millimeters. Stadin 100 millimeters at the idozino iter. Now I go to the find loading on the slabs. Loading on the slabs. Loading shear pick out weight of the steps, as we know. Weight of the steps, point. Self weight, steps plus west. Self weight, akata 0.18 times 0.3, 300 millimeters, times ustuchuar. And this is equal to, weight of slab. This is weight of slab. This is weight of slab. Weight of slab. Steps. Step. This we call the step. This is called step. Kata 0.18 times 0.3 times 24. And this is equal to 0.648 kilo Newton per step. Each step has this weight. Har step I wasn't here. Now weight of slab or west. This thickness, weight is equal to thickness. We found the thickness 0.1 في أبيتها 0.1 في 0.3 steps just for 3 5 شو كان يوم ويتكي أيرد معناه as we know this length this is 0.18 this is 30 well this angle is 31 or we can depend on Pythagoras this is equal to with equal to 350 millimeters. Then this is 4.350 times بس 12 then this is for 1 steps. Now weight of applied load. Applied load here dead load, applied dead load, weight of tiles, kashi plus weight of and mortar. Let's say and mortar ليرة 8 سنتيمتر 0.08 centimeters for one weight for above applied on the steps I can 4.3 times 23 gamma of the tile 23 here we found now for each steps we found 0.2 kilo Newton per step. Here is also 0.8 kilo Newton per steps. Now total dead load on the steps. Total dead on the steps. 2 kilo Newton per step. Now we have live load also. Live load per step. We have 3. Given in the problem, we use it for this stair, applied kilo Newton per meter square times 0.3 applied on the steps. Yaksana bachan aka 0.9 kilo Newton per steps. Each step subject to 0.9 kilo Newton. 0.9 kilo Newton. إذن استوى من هي زانيمان. Now total load or ultimate load is equal to 1.2 dead do 0.8 plus 1.6 live times 0.9 أكسانا وشان يكسانا سي 8 kilo Newton per step. Don't forget per steps. Now I found the moment also. I try to find the moment. A moment is equal to what? Is equal to W, can't lever. Now this loads is equal to W is equal to 3.89 kilo Newton per steps. Kilo Newton per steps. Each steps subject to 3.9 per step. This is cantilever. M is equal to G equal to W في L times L over 2. This is equal to W L square over 2. W L square W كانت 3.89. Here this distance we have this distance. This distance is 1 meters ln. While this distance from the center in moment we found the moment plane L plus 0.1. This 0.2. This is given in the problem 0.2 يعني دوسات millimeters. Centrica 0.1 إذن L لكسانا إذن لكسانا times 1.1 square over 2. 1.1 square over 2 is equal to 2.35 kilo Newton meter. طلع لي pure steps. Pure steps. Now it's required to find the edge. B is equal to 300. Okay, this is steps for one step. H and H, we have variable edge. This is edge, or this is another edge. This is edge, or this is another edge. This is edge. This is edge is equal to 100 millimeters. This is 100 millimeters. Therefore, this is 100 millimeters. This distance أكابشان أقرأ 100 millimeter أما أكابشان. This is alpha. Alpha is equal to 31 degree. Depend on 300 or 180. Now it's required to find this distance also from here to here. أكابشان. أو أدوزينو صد كوساين ألفا شيكا كوساين ألفا. Alpha akata sat over y1. For example, this y1. Then y1 is equal to akata 117 millimeters. Cosine alpha is now. See it? Akata satu hafda millimeters. Now او satu hafda. وش satu اشتا؟ akata do satu hafda زائدا اشتا akata do satu nawatu haft milli. Now for edge, we take the average edge. Average edge. y1 plus y2. y1 plus y2. This is y1. y1 is equal to 117. y2 is equal to 297. Over 2 average is equal to 207 millimeters. 207 millimeters. Okay. Now the edge, we take the average value for edge in the stair. We do for the cantilever. We do the steps edge. We found the edge in this way. وشيا كان استا ايج معناها استا ديت وايم دوزينو دي شيا كان اكاتا دو سطو حفت minus cover this is equal to cover here is 20 و minus phi we use phi دوانزا over 2 phi 12 over 2 is equal to دي كمان شنكات سطو هشتا دو ملي. Now design for this reinforcement moment is equal to what? Moment is equal to 2.35 times 10 to the power 6.9 AS FY D 182 minus AS unknown FY 420 F 1.7 F prime C 28. The width here, the width is B is equal to 300 millimeters. For the steps 300 millimeters. The only unknown in this equation AS we can found from second order, we can find is equal to 35 millimeter square. Here, this reinforcement occurs in this location. We must put cantilever. In cantilever, we put the reinforcement at top of the members. At top. Here, at top. At top. In each steps. At top. In each steps. And this way. In each steps. At top. This is at top. Because it's very small, therefore it's required to check AS minimum. AS minimum is equal to 0.0018 times B times edge 0.0018 times B 300. Edge, we found the average edge, do satu haft, and this is equal to 112 millimeter square per step. Everything per step. This is per step. Per steps. Now, yek 12 over we use phi 10. We use phi 10. Haftaosh min, exane 1.4 bars per step. Then use 2 phi 10 millimeter at top of each step. At each step. We design for each steps. Now we check the temperature and shrinkage and temperature enforcement. We check the shrinkage and temperature reinforcement. Now I check it. As we know, we have 0.0018 times B times H, it's similar, times B times H, 112 millimeter square per step. Maximum spacing between the bars, either 5H or this is structural 3H or 450. 3H or 450. 3H 3 times 100. 3 times 2 sorry 2 3 times 2 أكاتا 3 times أكاتا شصته 612 millimeters or 450 millimeters. We take the less distance for secondary. This is 450 millimeters. Where we use, this is the less distance. Here we found 112 is equal to this is divided by half tau hash. This is equal to 1.44 bars. 114 bars. Now let's require maximum spacing according to the A side. 3H is equal to 3 times 207, and this is equal to شرصته بستوياك or شرصته بنجا مليم. Now 1000 divided by 1.44 bars in each meters, we get is equal to شرصته نوت بنج مليم. We have this distance, we got this distance, we got this distance, we got this. We take the less value, we then use, we take the less value, we use the less value, use for secondary reinforcement, temperature and shrinkage, use 5, 10 at 405 millim center to center. Now, here we put the reinforcement, I put here the reinforcement. Now I have secondary reinforcement here. 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 This reinforcement, I have secondary reinforcement in the direction. This reinforcement, all this reinforcement is secondary. We use 510 at 450 millimeters center to center, except this is these two bars here at top. We use 2, 5, 10 millimeters. This is main bar. Yes, it is very small, but it is main bar. شو كم أصبر it's main bars. This is main bars at top. The at top is main bar. The other distances are 450 millimeters. Certainly, also you must check the shear. Check the shear also. Well, we found we have external applied shear. We can find external applied shear. We have the loss. Well, we can also find external applied force shear. We can find applied shear V ultimate, where we found 5 VC over 2, where no stirrup requires, no stirrup requires a 20 helic.